Welcome to our deep dive. So today we've got this really fascinating stack of architectural notes to go through.
Yeah, and they are, well, they're honestly quite unnerving when you really start to look closely at them.
They really are. We're looking specifically at an analytical framework called Mini Fields-based LMOS version 1.1.
Right.
And within that framework, there's this specific operational observation log titled STA-9.7.
Which is just a deeply uncomfortable document to read.
Totally. And our mission today is to use this LMOS framework to examine a very specific, totally invisible condition that plagues modern systems. Because, normally when we think of a system breaking down, we expect it to be like loud.
Oh, sure, alarms ringing,
Yeah.
error messages everywhere.
Exactly. We expect a global supply chain to dramatically grind to a halt or servers to just crash. We have this really ingrained assumption that failure announces itself.
Right, we are completely conditioned to look for the smoke. For us, a broken engine is loud, it's obvious, and it demands immediate attention. We treat system health as this binary state.
Right, like an on-off switch.
Exactly.
Yeah.
Either it's functioning smoothly or it is visibly on fire. There's no in-between.
But the source material we're digging into today, this STA 9.7 log, it basically argues that we're completely missing the most dangerous kind of breakdown.
Yeah, a breakdown with absolutely zero smoke.
None. The document describes a state that fundamentally does not appear as a problem. There are no alarms. It's a condition where basically connections exist, but nothing actually moves.
It is so unsettling.
Okay, let's unpack this.
Yeah.
Because how is it possible that a system isn't broken, yet it completely fails to function?
Well, the profound discomfort of this state really can't be overstated. We're looking at an environment where, digitally speaking, all the formal connections exist.
The APIs are talking.
Right. The APIs return successful status codes. The microservices are handshaking perfectly.
Dashboards are just like a wall of green check marks.
Exactly. The service level agreements, the KPIs, they aren't just being met, they are actively hitting these optimized benchmarks. But on the side of reality, in the physical, tangible world, absolutely nothing is moving. It's not broken by any standard metric we use, but it does not function at all.
So if you're listening to this right now, you are probably thinking, wait, how is that even possible?
It sounds like a paradox.
Right. If a system achieves literally nothing, wouldn't it throw some kind of error?
You would think so, yeah.
But to understand why it doesn't, we have to look at how we kind of arrived at a place where an architecture can be completely successful on paper while doing zero real-world work.
And that's where the LOS framework comes in.
Right. It gives us a specific rule. It says we have to prioritize, quote, structure over impression. We have to ignore the impression that things are fine.
Ignore the beautiful green dashboards.
Exactly. Ignore the perfect uptime metrics and dissect the underlying structural mechanics.
That structural lens is just vital here.
Mhm.
Because LMOS version 1.1, it basically acts as a diagnostic tool for systemic behavior. And when we apply it to that STA 9.7 observation, we uncover this massive, completely silent shift in how modern architecture defines the very concept of success.
Yeah, let's look at the mechanics of that shift. Because historically, if you think about what a successful transaction meant in a system, it actually required two distinct things.
Right, the two-part validation.
Yeah, first, a connection had to exist, the digital handshake, the routing of the request. But second, an action actually had to occur in the physical world.
Like a valve opening in a pipe.
Exactly. A payment clearing a physical bank or a server rack powering up, there was a physical result.
But over time, systems had to scale. We moved toward these massive distributed architectures. Asynchronous computing, decoupled microservices.
Because speed became everything.
Right. And measuring a physical action is computationally expensive.
It's slow.
It is incredibly slow.
Yeah.
It requires the system to stop and wait for real-world verification, which, creates massive bottlenecks.
So what do we do?
Well, measuring a digital connection is nearly instantaneous. It's frictionless. So, structurally, the definition of success was just redefined.
Simplified.
Exactly. Success became equated simply with the validation that the connection was made, period.
Wow. So the actual effect, the physical action that was the entire reason for building the system in the first place was just dropped.
Quietly decoupled and completely dropped from the core criteria of a successful ping.
Wait, so it's like we are confusing the receipt for the actual meal. The system gives us the receipt, so we just assume we've eaten.
That is exactly it. What's fascinating here is how this creates a permanent separation. We are left with a formal connection, the receipt, the ping, the digital handshake.
But it's totally severed from reality.
Right. It's severed from what the text calls functional disconnection. You have no meal, no real-world movement.
So just to visualize this, it's like a machine where pressing a button makes all the lights flash, right? The dials spin, it makes all the right noises, it gives you all the feedback of operation. But inside the casing, absolutely nothing is running. No gears are turning.
Yes, the feedback loop is completely isolated from the physical mechanism. It's a formal connection masking a functional disconnection.
Okay, if we want to really grasp the sheer scale of this illusion, we need to take this abstract structural theory and ground it in a concrete reality.
We definitely do, because it sounds almost too theoretical until you see it in practice.
Right. So the notes detail this incredibly common logistic system. Let's unpack the architecture of just a standard online order.
The warehouse scenario.
Yeah.
Yeah, this is perhaps the most glaring illustration of the blind spot. It exposes exactly how a system blinds itself.
So picture this. You place a complex order online. Your request hits the front-end application. It gets routed through an asynchronous message broker. Right?
Standard procedure, yeah.
The payment gateway microservice validates the funds. It returns a 200 OK status.
Perfect.
The inventory service gets the payload, decrements the digital stock count, and fires off a webhook to the fulfillment center.
Right. And then your app updates.
Exactly. The dashboard updates your status to completed and dispatched. From a software engineering standpoint, that architecture just executed flawlessly.
Flawlessly. Every single node in that distributed system did exactly what it was programmed to do. The data packets were routed, the tables were updated,
All the boxes checked.
the formal connections were verified across the board.
The physical box never actually leaves the shelf.
The jarring mismatch between the narrative and reality is just incredible here. Everything is processed, yet absolutely nothing arrives.
Nothing moves.
Right. The physical logistics could be entirely paralyzed. The forklift could have a dead battery.
The loading dock could be on fire?
Exactly.
Yeah.
The physical warehouse might not even have the item in stock because a previous physical audit got skipped. But to the digital architecture,
None of that matters.
none of it matters. Because the message bunker successfully delivered the payload to the warehouse's local server, the overarching system detects absolutely zero errors.
That is wild. The system's narrative is a story of total optimized success, while the physical reality is literally stagnant.
And the LMOS version 1.1 framework actually maps this out by dividing reality into distinct layers to help us locate this exact disconnect.
Right, the observation field module. Let's break those layers down.
So you have the N layer, which is the narrative.
That's the dashboards, the UI.
Exactly. Then you have the I layer, the intentions or the business logic. And finally, the OS layer, which is the operational system. That's the physical, moving, breathing reality.
So in that warehouse example, the N layer, the executive dashboards and the daily reporting, it's operating purely on the data passed by the API.
Yeah, and it is shouting that the system is functioning at peak efficiency.
Right. But then you have the OS layer. The concrete floor of the warehouse, the cardboard boxes, the actual human labor. And there is just this massive canyon between the N layer's celebration and the OS layer's standstill.
And that canyon introduces a dynamic that the text calls speed and shear.
Let's dig into that, because this isn't just about the layers being different. It's about the velocity of that difference, right?
Oh, absolutely. Systems function at drastically different clock speeds depending on which layer you're looking at.
Right.
The digital metrics, the APIs, the data in the N layer, they move at the speed of light. They face almost zero physical resistance.
Just bouncing off satellites.
Yeah. But the OS layer, the physical world, it moves at our speed, real world speed.
Bound by physics.
Bound by thermodynamics, traffic, weather, friction, human exhaustion.
So when we design architectures that prioritize asynchronous communication, we are basically hard-coding the N layer to just not wait for the OS layer.
Precisely. System A sends a command, System B acknowledges receipt of the command, and System A moves on.
It doesn't hang around to see if System B actually lifted the heavy physical box.
No, because that would slow down the processing time. The structural friction between those two speeds is the shear.
The shear. Wow.
The digital metrics compound incredibly fast, registering thousands of successes a minute. Meanwhile, physical reality is static. The formal connection is literally tearing away from functional reality.
Because the velocity of the data just vastly outpaces physical verification. Okay, here's where it gets really interesting.
Yeah.
Because if a system continually believes it is succeeding while actually doing nothing, what is the ultimate endpoint? We have to look at the long-term implications of this structural blind spot.
And this is where it shifts from being a technical glitch to something much more, well, profound. The text introduces the concept of the accumulation of non-functional success,
The accumulation of non-functional success, that sounds chilling, honestly.
because the formal connections are made flawlessly. No corrections are ever initiated. The system doesn't just sit there. It actually continues to optimize itself.
Wait, it optimizes?
Yes, but it's optimizing for hollow indicators. It's finding faster and more efficient ways to send the signal without ever checking if the action happened.
So it gets better and better at being completely useless.
Exactly. And this leads to the deepest tension in the source material. In this environment, failure no longer exists as a category.
Failure just disappears.
If failure isn't defined by the architecture, then it simply doesn't exist. And if failure isn't defined, no one is responsible.
So wait, what does this all mean? If the system never registers a crash, if it never throws an error code, how does it end?
That's the thing. We always expect a collapse to look like an explosion.
Right, sparks flying, servers down.
We expect a catastrophic server wipe. But because these success metrics just keep piling up and piling up, the collapse doesn't look like an error at all.
What does it look like?
It manifests as a total loss of meaning.
A loss of meaning.
Yeah. The word functioning loses its definition. The architecture is sound, but is this philosophical void where physical action used to be.
I mean, I have to admit, from a purely technical standpoint, building an algorithm that can adapt and keep hitting its metrics no matter what happens in the physical world, that is a mechanical marvel.
It is an incredible feat of engineering, sure,
Yeah.
but it's a marvel that governs a graveyard.
Wow.
The map is flawlessly rendered in high definition, updating in real time, completely oblivious to the fact that the actual territory underneath it has eroded away entirely.
So the system is thriving, but reality is collapsing.
Exactly, and the dashboard is just glowing green the whole time.
This leaves us staring at a really profound dilemma, because if you're listening to this, you interact with these decoupled systems every single day.
They all do.
We rely on that end layer to tell us the truth about the physical world. We trust those flashing green lights on the console. You exist in a world where the validation of a connection has been completely severed from its actual impact.
It really forces us to grapple with the philosophical unknowns that the STA 9.7 thesis leaves us with.
Yeah.
We have to ask ourselves, what actually is a connection?
Right. Is making contact just about a signal passing through a firewall?
Or is it fundamentally about an action occurring? When does a perfectly executed non-functional contact finally cross the line into being a failure?
And right now, the system's answer to that is simply never.
The formal connection remains completely intact.
In a world where the very definition of success has been subtly, quietly faked by the systems we rely on every day, where do you place your trust? How do you judge if something in your own life is actually functioning?